So in this video, we're just going to apply all of the different trig equations and rules, sine rule, cosine rule, and regular right angled trig to answer a few miscellaneous trigonometry problems. So there's going to be two examples where we're going to apply some of these things that we've learnt. Now, in example one, we're trying to find, we have a block of land here, and we're trying to find first the length of x. Now, if you look at this block of land, it's a quadrilateral, it's four sides, but we can split this into two smaller triangles and try to identify a way to apply what we've currently done and what we've learnt. So if you look at just this triangle here, we notice that there's three sides in question. We've been given two and we have an unknown one and one angle. Now, anytime we have three sides and one angle, we want to use cosine rule. So for part A, we want to use cosine rule and we're trying to find a side. So we'll call this X side C. We'll call, that means 70 will be angle C. 320 can be A and 210 can be B. So using cosine rule, we know that x squared equals to 320 squared plus 210 squared minus 2 times 320 times 210 times cosine 70. So just to find x, we are going to square root this entire expression. So I'll go 320 squared plus 210 squared minus 2 times 320 times 210 times cos of 70. Now, if you want to go straight into this step, that's fine, just as long as you made some reference to the fact that you are using cosine rule here. Now, we want to find this correct to the nearest meter. So in our calculator, we're going to go 320 squared plus 210 squared minus 2 times 320 times 210 times cos of 70 degrees. And we're going to get 317.068 ... which to the nearest meter is just going to be approximately 317 meters. Now, part B is following on from part A because with part B now, we are considering the other triangle we see here by splitting the quadrilateral. We are looking at this one here. Now, we notice here that we've been given two angles, 38 and 82, and we have two sides. One of them is the x that we've already found. The other one is the unknown y. So writing this in for part B. Now, we've rounded in the first part, but because part B follows on from that one, we can either use the rounded value or the exact value. You won't get penalized for using one or the other in an exam. Now, we've been given two angles, two sides, so we want to use sine rule. So we know that using sine rule, we can use our side y. So y over the sine of the angle opposite that. So sine 38 degrees equals to 317, which we got from part A, over sine 82. Now remember, we need the opposite side. So it's the side and the opposite angle. Here, it's the side and the opposite angle. So if it comes in a question where it's not actually the angle opposite, you will need to go another way around, maybe using the angle sum of a triangle to identify that third side. Now, since we know this, we can, now that we have our equation, we can rearrange it. To get y on its own, we're going to multiply sine 38 to get it to the other side. So we can say that y is going to be 317 over sine of 82 multiplied by sine of 38. And I'll just go straight into the rounded answer. So once you get this, we want to round it to the nearest whole number, so to the nearest meter. So we put 317 over sine 82 multiplied by sine 38 into our calculators, and that will give us 197 meters. So we're applying sine rule and cosine rule, but in a not so obvious way. This is why we call it a miscellaneous trig problem, because we're using it and applying it to a different context. Now, example 2, Can read through the question, but it's good we have a diagram here. We have an angle of elevation to the top of a wall of 32 degrees, and a person walks horizontally 10 meters. So 10 meters is just this length here, and then measures the angle of elevation as 51 degrees. And we want to find the height of the wall. So for this one here, we can do a couple of things to get around a problem like this. Now, we're missing a bit of information, okay? So we can't just use trigonometry, right angle trigonometry easily to find the height h, because we're only given this part here, this length of 10. One thing that we can use though, is we can use the fact that this is 51 degrees to find this angle here, because they're supplementary angles. So this angle in here, we can get by doing 180 minus 51. So once we do that, that will give us the angle, which will allow us to use some non-right angle trigonometry. So this angle in here is 129 degrees. So with that in mind, we now have two angles, and we can use the side here and another side that's opposite that angle we just found, and use sine rule, because we have two angles, this one, and two sides here. So let's call this side x. So we can use our sine rule. So we can say x over the sine of the angle opposite it, which is 129 degrees, equals to 10. Now, we have to pause here because we can't actually use sine rule yet. We have our side, but we don't have the angle opposite it. We need this angle in here. So to find that one, we remember the angle sum of a triangle is 180 degrees. So we want to subtract 32 and 129 from that. By doing that, it's going to give us that third angle, the angle that's opposite my side 10. Remember, we can't use sine rule until we have the angle opposite the given side. So this is going to be 19 degrees. So we have 10 over sine of 19. So now that we have this, we can rearrange the equation to solve for our x on the numerator here. So we want to get the sine 129 away from the x. It's dividing. So we can multiply it across to the other side to find the value of x. So now that we've made x the subject of the equation, it's on its own, we can put this into our calculator. So 10 over sine 19 multiplied by sine of 129. That's going to give us, remember we're answering to the nearest meter, you have to read the question. This will give us 23.87 ... And rounding to the nearest meter, that gives us 24 meters. So that is the height of our wall here. That brings us to the end of the video. This is how we can apply some of our non-right angle trigonometry to these worded questions and these just miscellaneous problems that require us to use multiple concepts. Thank you so much for watching, and I'll see you next time.